It's a scientific fact that the hormones of stress downregulate genes and create disease, long-term effects. Human beings, because of the size of the neocortex, we can turn on the stress response just by thought alone. We can think about our problems and turn on those chemicals. That means then our thoughts could make us sick. So if it's possible that our thoughts could make us sick, is it possible then our thoughts could make us well? And the answer is absolutely yes.
Stress is a feeling we all experience when we are challenged or overwhelmed. But more than just an emotion, stress is a hardwired physical response that travels throughout your entire body.
All organisms in nature can tolerate short-term stress. You know, a deer gets chased by a pack of coyotes. When it outruns the coyotes, it goes back to grazing and the event is over. And the definition of stress is when your brain and body are knocked out of balance, out of homeostasis. The stress response is what the body innately does to return itself back to order. So you're driving down the road, someone cuts you off, you jam on the brakes, you give them the finger, and then you settle back down and the event is over and boom, now everything's back to normal. But what if it's your coworker sitting right next to you and all day long you're turning on those chemicals because they're pushing all your emotional buttons? When you turn on the stress response and you can't turn it off, now you're headed for disease because no organism in nature can live in emergency mode for that extended period of time.
In the short term, stress can be advantageous, but when activated too often or too long, your primitive fight or flight stress response not only changes your brain, but also damages many of the other organs and cells throughout your body. Your adrenal gland releases the stress hormones cortisol, epinephrine, also known as adrenaline, and norepinephrine. As these hormones travel through your bloodstream, they easily reach your blood vessels and heart. Adrenaline causes your heart to beat faster and raises your blood pressure, over time causing hypertension. Cortisol can also cause the endothelium, or inner lining of blood vessels, to not function normally. Scientists now know that this is an early step in triggering the process of atherosclerosis, or cholesterol plaque buildup in your arteries. Together, these changes increase your chances of a heart attack or stroke. When your brain senses stress, it activates your autonomic nervous system. Through this network of nerve connections, your big brain communicates stress to your enteric or intestinal nervous system. This brain-gut connection can disturb the natural rhythmic contractions that move food through your gut, leading to irritable bowel syndrome, and can increase your gut's sensitivity to acid, making you more likely to feel heartburn. Via the gut's nervous system, stress can also change the composition and function of your gut bacteria, which may affect your digestive and overall health. High levels of cortisol can also cause you to put on those extra calories as visceral or deep belly fat. This type of fat doesn't just make it harder to button your pants. It is an organ that actively releases hormones and immune system chemicals called cytokines that can increase your risk of developing chronic diseases, such as heart disease and insulin resistance.
In normal circumstances, bacterial infection results in the release of chemokines that attract circulating neutrophils to the endothelium. This process is known as chemotaxis. A variety of molecules are expressed on the endothelial cell surface that allow the neutrophil to be captured, then roll along the endothelium, then adhere. Following adherence, the neutrophil migrates into the subendothelial tissue to reach the site of infection. The neutrophil engulfs the bacteria and eliminates them via breakdown within the phagosomes, a process known as phagocytosis. In states of hyperglycemia, chemotaxis is reduced. Adherence is also adversely affected. Phagocytosis is also impaired by hyperglycemia. Hyperglycemia also adversely affects the macrophage system. Under normal circumstances, circulating monocytes are attracted to sites of infection, roll, adhere, and then migrate into the subendothelial space. The monocyte then transforms into a macrophage, which is then activated by cytokines released by the bacteria. The activated macrophage then engulfs the bacteria. However, hyperglycemia results in decreased activation of macrophages, thereby arresting the process of macrophage phagocytosis of bacteria. In addition to affecting neutrophil and macrophage function, hyperglycemia also affects the complement cascade. Under situations of normal glycemia, bacteria can activate the complement cascade. Activation of the complement cascade results in the formation of transmembrane protein channels, known as membrane attack complex, MAC, in bacterial membrane. Membrane attack complexes make the bacterial membrane porous, and the rapid influx of fluid results in the bacterial cell death. Hyperglycemia inhibits the proper activation of the complement cascade, thereby reducing another pathway of the immune system.
Meanwhile, stress hormones affect immune cells in a variety of ways. Initially, they help prepare to fight invaders and heal after injury. But chronic stress can dampen the function of some immune cells, make you more susceptible to infections, and slow the rate you heal. Want to live a long life? You may have to curb your chronic stress. That's because it has even been associated with shortened telomeres, the shoelace tip ends of chromosomes that measure a cell's age. Telomeres cap chromosomes to allow DNA to get copied every time a cell divides without damaging the cell's genetic code. And they shorten with each cell division. When telomeres become too short, a cell can no longer divide, and it dies. As if all that weren't enough, chronic stress has even more ways it can sabotage your health, including acne, hair loss, sexual dysfunction, headaches, muscle tension, difficulty concentrating, fatigue, and irritability.
The stronger the emotional reaction you have to some experience in your life, the more you pay attention to the cause. And the moment the brain puts all of its attention on the cause, it takes a snapshot, and that's called a memory. So long-term memories are created from very highly emotional experiences. So what happens then is that people think neurologically within the circuitry of that experience, and they feel chemically within the boundaries of those emotions. And so when you have an emotional reaction to someone or something, most people think that they can't control their emotional reaction. Well, it turns out if you allow that emotional reaction, it's called a refractory period, to last for hours or days, that's called a mood. I say to someone, hey, what's up? You say, I'm in a mood. Well, why are you in a mood? Well, I had this thing happen to me 5 days ago, and I'm having one long emotional reaction. If you keep that same emotional reaction going on for weeks or months, that's called temperament. Why is he so bitter? I don't know, let's ask him. Why is he so bitter? Why are you bitter? Well, I had this thing happen to me 9 months ago. And if you keep that same emotional reaction going on for years on end, that's called a personality trait. And so learning how to shorten your refractory period of emotional reactions is really where the work starts. So then people, when they have an event, what they do is they keep recalling the event because the emotions of stress hormones, the survival emotions, are saying pay attention to what happened because you want to be prepared if it happens again. Turns out most people spend 70% of their life living in survival and living in stress, so they're always anticipating the worst case scenario based on a past experience, and they're literally, out of the infinite potentials in the quantum field, they're selecting the worst possible outcome, and they're beginning to emotionally embrace it with fear, and they're conditioning their body into a state of fear. Do that enough times, the body has a panic attack without you. You can't even predict it because it's programmed subconsciously. The hardest part about change is not making the same choices you did the day before, period. And the moment you decide to make a different choice, get ready because it's going to feel uncomfortable. I think that the bigger thing is that we keep firing and wiring those circuits. They become more hardwired. So you have a thought and then the program runs. but it's the emotion that follows the thought. If you have a fearful thought, you're going to feel anxiety. The moment you feel anxiety, your brain's checking in with your body and saying, yeah, you're pretty anxious. So then you start thinking more corresponding thoughts equal to how you feel. So the body says, I want to return back to familiar territory. So the body starts influencing the mind, and it says, start tomorrow. You're too much like your mother. You'll never change. This isn't going to work for you. This doesn't feel right. And so if you respond to that thought as if it's true, that same thought will lead to the same choice, which will lead to the same behavior, which will create the same experience, which will produce the same emotion.
What does all this mean for you? Your life will always be filled with stressful situations, but what matters to your brain and entire body is how you respond to that stress. If you can view those situations as challenges you can control and master, rather than as threats that are insurmountable, you will perform better in the short run and stay healthy in the long run.
You can't go back and change the beginning, but you can start where you are and change the ending.